So a friend of mine that owns a Intex Pure Spa brought me in the pump unit of his to work on. So it's going to be somewhat similar to this picture here. And I have the actual pump unit, and it is a SSP-H-10-1. It's around 1300 watts heating, 50 watts at 12 volts for the pump, and 800 watts on the bubbler or the little air blower. About 460 gallons per hour rated on the flow rate. And I'm going to have to rig this pump up temporarily just to circulate water so I can troubleshoot it. So I've rigged up a 5-gallon bucket with a fitting here with some 1-inch pipe. That's the inlet, and I just got the return coming back to the bucket. And at this time the sun's on the display here, but we're at about 94 degrees here. So I have this powered on, and the filter is turned on, as you can see by the green filter light, and the red flame is showing that the heat is actually on and heating up at this time. If I just take my infrared gun here, so around 95 degrees, and if we look at the display here, let's block the sun. Yep, 95 degrees on the display, so that's verifying a correct reading there, and we have a set point of 100 degrees. I'm just going to let this run throughout the day and just periodically be around checking on it, and we'll have some video of the updates, and hopefully we'll catch it given an error. My friend said the temperature would start kind of rising and then it would give a E96 fault, is what I believe he said. So I just have the hose down in here simply returning, and it should heat up fairly quick. And this part here is just for the bubbler where the air would blow in if you wanted to cut on the bubble feature. And we just so happened to catch this messing up right here on video. So it was not even at temperature yet, and then it started showing like 106. As you can see, the flame light is not showing at all, green or red, so it has faulted out. And we're still getting that flashing E96, which some of the only help I've seen in troubleshooting for this has been that it might be a controller issue. But I'm just wondering if it's not something going on with the temperature sensors, because it did start going up. Like maybe we had a misread on one of the sensors, and we see now it's at 112. And the only way to get out of this is to cycle the power to the unit and restart it. And after letting this sit a while, we're still showing 116 degrees. And even though I've separated these buckets out a little bit, this is still the same temperatures. The water's just been split between these two buckets, and we're only around 86 degrees, so we're showing over 30 degrees difference, so that's pretty substantial. So we're going to have to get into this and see what these sensors look like. And here I am back now. I have it unplugged. I believe these plastic hex head bolts are 12 millimeter, or take a 12 millimeter hex wrench. And I actually don't have one, but I do have a bolt that has a 12 millimeter head. I'm just going to chuck at my drill and remove these 3 larger plastic bolts, and the display unit pops off like so. And we just have a connector here. It looks like it just unplugs. So that's what it looks like. So now to remove the cover, it looks like we just have 4 Phillips stainless steel screws. And just so you know, these actually have a nut that goes in the bottom of the base unit, and sometimes they will drop out on you, and you definitely don't want to push down on the screw because it will push that nut down out of the holder. And now this should just slide off. I do have the wire connected, and I do see some spider webs here, and I'm definitely taking my time to look around for spiders. But I'm going to replay this and share here. I don't know if you saw it on video or not, but as I'm looking for spiders, one of my right fingers was within a ½ an inch of a black widow right here in this shot of the video. I didn't see it under that inside cover. I'm starting here to look around and make sure there's none around the heating unit, and I'm looking for the sensors. And here I actually glance over. I saw some legs of that black widow moving around. Let me go get the camera here so I can see his legs from the top here. And yeah, I have my fingers really close to this little rascal. So I'm also going to take this cover off. It's just 4 Phillips screws in the corners here, and we're going to look at this board. We're going to make sure we don't see any corrosion or any bad connections. And I will say this thing is really well protected, and I was pleasantly surprised at just how well it looked and just how good a shape this board was in. I mean, all the connections look good. I'm going to go through and make sure with a screwdriver that all the connections are tight, and all the capacitors look good. No bulged caps, nothing obvious, no corrosion, no hot spots around like the transformer or the the cap over here on this part of the power supply. It looks good. We do see these relays here for what I assume is like multiple staging of the heat. So instead of solid state control, it looks like it's using relays, even though we have a heat sink here. So it may be doing both, and we're also probably using the relays for the pump and the blower as well. And this looks like bonding for the ground wires. Looks like all that is the junction. I'll put that back. But all our connections here look really good and clean, and all look tight, but I will double check them like I said. And these are the connectors for your sensors, and no corrosion there, and everything looks good and connected well. So let's turn this around here and start looking at these sensors. They have inline connectors as well, so we'll definitely look at that in just a minute. So let's go ahead and take this sensor out. Remove one Phillips head screw here, and I believe this is going to be a flow sensor because of the way it's made, almost like a type of reed switch that may just pick up flow, whether it's the movement of a paddle or something like that. I'm not 100% sure, but this absolutely looks like a temperature probe, like an NTC thermistor, and it takes a 13 millimeter to remove it. So we're just going to unplug it. It has the O-ring and just a couple threads, and it comes right out. And it's in plastic, so we're definitely going to be careful going back with this. It's definitely dirty, but I don't believe it's supposed to be shaped like this either. We're going to clean it off and see if we can get it back working. But if we look online, this is what some similar spa thermistors look like. So I can't guarantee that's what these look like originally, but I am pretty sure that they did. And you can just see here that possibly the plastic of the NTC itself is showing through the metal, which is not good. I'm just going to use some 91% alcohol here and clean these up really well and just see if we have any luck getting them going. Some debris is coming off, but mostly it's just corroded. The soft metal is just eating away. And I really believe that is just a sensor. If you see now cleaned up, that looks like the plastic tip of the NTC just sticking out. And on the side of this NTC, the writing is 1434. So whether that's the resistance of this sensor at a certain temperature or not, I'm really not sure. Just putting a meter on these in room temperature, they're around 10K. So I believe they're just regular 10K thermistors. Once the O-ring touches, I'm just going to go about a quarter turn here. I just don't want to over tighten these, as I only have a couple threads as mentioned going into that plastic housing. So if we look at the connector on this flow switch, it looks good. And of course the connection on the NTC we just looked at looks good. So let's put the hold down clamp back on this flow switch, and we'll look at the other side. One thing I'll mention really quick here is this is a bridge rectifier. Looks like it goes up to power the board. So now we're going to remove the NTC on this side. And looks like I got to cut some tie wraps here, but it's this white connector up here up top. Has a longer lead than the other one. Here we go, we got some snips, just a couple tie wraps here, and there we go. Also 13 millimeter. And looks like the water has eaten it up as well, and it did have some debris on the very tip of it, and this looks like it's the same type sensor. It just has a longer lead and a different connector, but it looks the same. We're going to clean it up with some alcohol as well. And 1433 is the writing on this one. So 1334, 1333. The threads feel a little bit weaker on this one than the other one. I'm just going to barely turn this one past contact point. We're going to connect it back up. Add some tie wraps. I'm going to put the cover back over the control board and put the 4 screws in. We're going to put the housing back on, and here we do have to make sure we go in these slots on the left and right side here, as well as these little bubbler tubes up top. They have to line up, and there we go. I'll just put the 4 screws back in here. So back now we have it powered on and circulating and showing 87 degrees, which I believe is correct. We'll verify that. Let's go ahead and cut the heat on. I got my kilowatt plugged in here. Let's see what we go up to. Only about 41 watts or so with it powered on and just the pump running. And now here we go, the heat's starting to step it up. Over 500 watts now, over 600 watts, over 700 watts, now 1,000 watts. So there we go, about 1,200 watts, and we can see that our red flame is lit up. We are heating, and so if we double check it here with our infrared gun, yeah, we are 89, 90. After a little while, we are at temperature, so we're holding. We see the green LED on for the flame. Down to about 41 watts. Showing 102 here. That looks good. And by the way, I just threaded this 1-inch piece of pipe, just something I had around to help me get this connected up for testing. I just used this cheap pipe threader kit that I have around. It actually helped a lot since I didn't have any threaded pipe readily available. I just clamped this flexible hose here on the return for the pump up top here. It's pretty neat how they made these little pipe adapters split so you can remove them. So just a Phillips screw and able to remove these. I just slid my little flexible pipe on there just to get by temporarily for testing. It worked out pretty well. And I did give this back to my friend at work to see how well it would work for him. And it worked for a couple weeks, then it started throwing those faults again. So I thought we'd go ahead and buy some sensors. And these are the sensors I bought. These are cheap enough for sure, but they are M8. They are not M10. So I do want to mention that in case it helps someone else. It did show in the listing here that they're 10K temperature sensor probes, M8 and NTC. I knew the wire was plenty long enough, and I would just have to solder on my connectors. But one problem I had was the M8 thread, and the only ones I saw that were M10 not only were more expensive, and it wasn't just so much that, they also didn't say for sure that it was 10K. I do know that the threads on this Intex Pure Spa is M10. So looking at this one on Amazon, the only difference I see here really is the 14mm on the hex, which didn't really matter that much, but it did show it was M10 and the length was really close. So if these would have said they were 10K, I probably would have bought these, but it just didn't say for sure. So what I ended up doing was buying these adapters. So these are M10 to M8 threaded adapters, and they're stainless and they're cheap enough for sure to buy and try. And I actually liked how it worked out. They actually give you dimensions on here, which is very helpful. The 12mm was a really good length, and I was not 100% sure that the threads were going to be right since I didn't have that information on the sensors yet until they came in. But I want to share here that I did double check, and M10 by 1.5 was in fact the external dimension of the threads, and the internal threads were M8 by 1.25. So these ended up working out really well. I did leave the O-ring on the sensor, but I don't believe you really need to because it did try to pucker up a little bit. You just don't have much of a surface to grab with that threaded adapter, and it just wasn't enough threads there to really put a washer. I could have put a stainless washer, but just don't have many threads on them sensors. So what I did is I just left a little bit of thread sticking out in case I need to remove it, and I just put some pipe dope on the threads to seal it up, and it worked out really well. I did have to solder my connector on. I already had this style connector, but I did not have one like this white connector here. As you can see here, I just soldered them on and put heat shrink over the wires. And I also put the threaded adapter in. Instead of this way with the slide out where you can remove it and insert it easily, I did decide to turn it around and put the slot on the inside. So I just threaded mine on the sensor itself till it was snug with pipe dope, and then I threaded the whole thing in like you would normally. And one benefit to this is you were only getting a couple threads in that plastic, and now you have like 5 or 6 threads deep into the plastic with this insert. So I actually like this better than the way the factory one was, to be honest. So I did use some thread sealant like this Loctite here, or pipe dope as some call it. It definitely helped seal everything up well. So at the time of this video editing, the pump is still going strong for my friend and working well. So I definitely hope this took care of his issue, and I hope you found this video helpful. If you did, please like, share, and subscribe. I'm going to have some links down in the video description of these NTCs and adapters and some other tools that I find very helpful on my workbench. So any of those links you click on are affiliate links, and they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.